Now, I want to go ahead and do a complete setup tutorial for the Jetson Orin Nano Super. Historically, Jetsons perhaps may have appealed to a more niche audience who knew exactly how they were going to use it as soon as they got it. However, the new price point of this, coupled with the rise in interest in locally hostable generative AI, I do believe leads to a subset of the population who wants to get their feet wet with generative AI, sees this and says, hey, I want one, but I'm a little scared in how I actually go about setting it up and doing anything with it. So today, the whole point of this video is basically from the ground floor to go through all of those steps and ultimately leading up to running some LLMs, actually using this as a little AI server and running some image generation and things like that. Now, to jump right into it, there are a few prerequisites that we need to make sure we have on hand before we get going with this Jetson. The first of those being a computer, and that is going to be to actually flash the operating system onto this Jetson. And that leads me into the next prerequisite, which is a micro SD card. Now, it is suggested to have a 64 gig or above micro SD card, and being that we are going to be loading some generative AI models on this, which can take up a lot of space by themselves, I would say 64 could be a little low. I would be most comfortable personally starting at 128 at the minimum. And the card I have here is a 256 gig micro SD card. Following that, you don't need to have this, but it is an option, and that is an NVMe SSD just to add some more storage into this Jetson. Now, on the bottom side of this, it does have two NVMe SSD slots, a 2230 and a 2280. So I do have here a 256 gig NVMe SSD, and I will go ahead and actually show installing that for those of us who want to also go ahead and do that ourselves. To begin the process of getting our operating system onto the micro SD card, we're going to go to jetson-ailab.com. As this video progresses, we're going to become a bit more familiar with this website, but for now, we can just kind of think of it as a tutorial hub for things we can do with our Jetson. Now, being that the first thing we want to do is actually get the operating system on it, we can basically just click any one of these tutorials here because we want to go into the sidebar here on the left side of the screen and select Jetson Orin Nano Guide. And once we click that, we're going to go to the drop down there and click on Initial Setup Guide. Now, a quick disclaimer, the Jetson Orin Nano Super is identical to the older Jetson Orin Nano, sans a software update that allowed this to basically almost double the performance. So if you do have an older Jetson Orin Nano, a non-super, you can actually also follow along with these steps. However, as we see in this flowchart here, the process of actually getting it updated is going to be a bit different than what we're going to do here. And that is basically because the firmware on my Jetson here, and if you have newly purchased one of these, your firmware as well will be newer than version 36.0. And if we look at this flowchart here, we can basically see that that makes things a lot simpler. So I did just want to throw that in there in case you are attempting to follow along this tutorial with an older model. The process you have to follow is going to be a bit different than what I am going to show here. Now, basically, we see that we have our two prerequisites here. Well, one prerequisite and one optional prerequisite. And since we do have our micro SD card ready, we go down and we see the flow chart where we do select yes, because we can basically just go ahead and flash the operating system onto the micro SD card. Now we go down here, and because our firmware is 36.xxx, we can basically just go ahead and click this, which is going to download the operating system image onto our computer. Now, this is around a 10 gigabyte download, so it's actually around 11. So make sure you have ample free space on whichever computer you're going to be using to actually download and flash this to the micro SD card. Now, while this is downloading, we're going to actually need a software solution that will allow us to flash this image onto our micro SD card. And for that, they have recommended Balena Etcher, which is a great open source kind of program that I actually use a lot personally for a numerous amount of things. So I'm also happy to recommend using this. And being that I want this to be a complete setup guide, and also that I don't have this on this computer, we're going to go ahead and just go over actually how to install that as well while our operating system image is downloading. And I'm going to reject all cookies. And we're just going to click Download Etcher. They do make it quite simple. We're going to select the operating system that we're downloading it for, which, remember, this is for the actual computer that we're using right now and not for the Jetson. So this is just to have our computer flash the operating system onto the Jetson's micro SD card. So bear with me if that sounds a little confusing. It will make sense soon. Now, being that I am using Windows, I am just going to download the Bellina Etcher installer for Windows, and that will likely complete much quicker than the actual SD card image. And once that's done, I will click on the setup.exe file, and Bellina Etcher is open and ready for us to go ahead and use it. Now, I just need to finish waiting for this download, and once that's done, we'll go ahead and move on. Now that the download with the operating system for the Jetson has completed, we are just going to click on the file, and in my case it will open it in a file explorer here, and I am just going to extract it to a location that is convenient to me, and sure, that works fine. The default is downloads, and it may take a little bit of time as it is a rather large file, and once it is extracted, I do believe it's around 22.8 gigabytes or something like that. Now that we have finished extracting the downloaded file, we can see here that it is around 23.5 gigabytes, so a rather big operating system file. And again, that's part of the reason why a 64 gig micro SD card just might not be enough for this use case. Now, depending on the type of computer you have, you can either just directly insert the micro SD because you have a slot for that on your machine. But if not, you can also just make sure that you have an adapter to do that. They sell them on like Amazon or Micro Center or anywhere you can get these for cheap. But that is just something else you're going to want to have on hand so you can actually get the SD card loaded. Now, this laptop does have a convenient micro SD card slot, although you really need to push it in, like it's a little excessive. So I digress. The next thing we're going to do with the card in the computer is go ahead and open Bellina Etcher, which we have previously downloaded. And fortunately, Bellina Etcher is about as simple to use as it can get. So we're just going to click Flash from File, and we will go into our downloads where we have extracted the image. I will go into the folder containing the extracted image, and I will select Open once I have it selected, and it is named SD-blob. Now that I've done that, we are going to select our target, which in this case refers to the micro SD card that will be put on the or inside the Jetson. And I'm going to click this. It will give you a slight warning saying, hey, this is a large drive, just to make sure you're not accidentally like overwriting your hard drive or something like that if you do have a large SD card you're using like this one. So I click select and flash, and I'll probably have to enter my password. And you just double check again you're not overwriting your hard drive. Yes, I'm sure. And on Mac, it will ask you to enter your user password. Okay, and in this case, because this micro SD card was not brand new, I need to format it before I can use it. However, I should be able to just close out of this, and Bellina should do this by itself. So okay, and we can see right here that Bellina is actually already started to flash the drive. So all of that was just Windows kind of being a little confused, but I suppose that is good to show, because if you are going to be following along in these steps, you may also encounter that. So we can see this is going to take around 10 minutes to get done, and once it's finished, we will go ahead and get the Jetson booted up. Now, while the SD card is being flashed with the operating system, I do just basically want to go ahead and install this NVMe, and I want to show that. Now, you'll have to excuse any awkward angles here because I need to stay in front of my microphone while I actually go ahead and do this, so I am kind of reaching in odd positions and things of that sort. So I did just get this from Micro Center, and assuming I can open this packaging without cutting an artery, I should be good to go and get this installed. Now that we have the NVMe here on the table, and we have the Jetson as well. We're basically just going to go ahead and flip the Jetson over, and you're going to see two NVMe slots here. So there's this one, which you can see would be for a much shorter NVMe, and there's this one, which you can see would be for this one that I am using here. And essentially, all we're going to do is go ahead and try not to damage the Jetson. All right, so once we have removed that screw right there, or whichever screw corresponds to the slot that we are going to be putting the NVMe in, we're just going to want to spin this around and make note of the actual indentation in the slot, as the SD or NVMe SSD itself also will have a corresponding indentation. So you just want to make sure that those do match up so you can actually properly get it installed. And please don't mind as I do this with one hand and try to get it in. And if you've never installed one of these before, you're going to be like, why the heck is it like springy like this? It's like a diving board. They're like that. So that's really the purpose of this screw, is to kind of prevent that from happening. So once it's in, we're basically just going to go ahead and put this screw back in. And you don't need to make it super tight, just tight enough. And that really concludes the installation of the NVMe SSD in the Jetson. Now, to actually go ahead and use this as additional storage is a bit more involved, so later on in the video I will just have a separate section on how to actually go ahead and do that if you are interested. Now, once Balena has finished flashing and verifying our SD card, it will go ahead and likely auto-eject it, so basically you could just go ahead and remove it right now. However, for continuity and best practice, let's just make sure that it is not appearing still as plugged in our system. And since it isn't, we can go ahead and remove our SD card, which has now been flashed with Jetpack 6.1. And essentially, the best way to think about like what is Jetpack? Jetpack is to this Jetson what Windows 11 is to this laptop. So it's just its operating system. And now that we have our micro SD ready to go, we're basically just going to go ahead and plug it right into the Jetson. Now, this is admittedly actually a bit tricky to get in, so just make sure you're careful with it, and keep in mind that the gold contacts will be facing the ceiling when you put it in, so don't try to put it in upside down. And you'll hear the nice little click of the micro SD card slot once it's in, and basically we are now ready to go ahead and boot up our Jetson for the first time, which will of course require a monitor, keyboard, and mouse. Now, because I want this video to be as thorough as possible, I am just going to show plugging the Jetson in. So the first thing I am going to do is just put a little Bluetooth keyboard dongle in there so I can use a wireless keyboard just to keep things a little cleaner. Following that, I am just going to plug the mouse in, which unfortunately is not wireless, so it's, pretty simple, just plugging USB in. Now, I am actually using Ethernet for this, so I am just going to go ahead and plug in the Ethernet port. And the Jetson actually uses a DisplayPort cable. It does not use HDMI. So if you're not really familiar with that, or if you don't have a monitor that will accept that, you may need to get an adapter before you use it. And really, the final step is just going to be to plug the power adapter in. And that is essentially your on-off switch. So as soon as you plug the power adapter into the Jetson, you'll see the fan start to spin and it will turn on. Now that the Jetson is running, we kind of get our first look at what it looks like on a screen. Now, if my screen looks a little funky, bear with me for a second until the setup configurations are done, because I have this hooked up to an external capture card, so this screen right now is a little hard to see. Now, basically, we're just going to go ahead and go through some of the system configurations here. And if this does actually look a bit familiar to you, in specific the background image here, that is because this is a version of Ubuntu 2022.04. So first and foremost, we just basically need to go ahead and accept the end user license and the NVIDIA end user license agreement, which I do. So I will click I accept and continue. And following that, we're basically going to just be brought through the default setup of Ubuntu 2022.04, which is rather simple. There's not a lot to it. We'll select our time zone, which New York works for me. I am on the East Coast, not in New York, and then you want to just make a name for this device. So I'm just going to call it OMNS, and then you choose a password. And it is a weak password, but for my purposes, it does work. And you can either choose to require a password to log in or to log in automatically. I generally just have my systems log in automatically. So once that's done, you go ahead and click continue. And for this, we're just going to leave it exactly as it is. We're not going to touch this. So we're going to press continue. And following that, we will be asked whether or not we want to install Chromium browser. So if you are like myself and you prefer Firefox, you can say do not install and just go and manually install Firefox. But just to get this fluid and going, I am just going to have it install Chromium as well. And once we do that, it is going to basically open like a mini terminal here and actually go about installing Chromium. So once that is finished, we will move on. And once Chromium has finished installing, we will get a little message here and we can click close. Side note, I don't remember if I called it Chromium at first, but I meant Chromium. So just in case, because I haven't seen the footage back yet. And basically, we are now just allowing it to set up some system configurations and things like that. And once this gets done and we are brought to our desktop for the first time, we will also just have a couple other menus to go through. And right now it's essentially just removing some of the dependencies that were necessary for this to allow us to set it up on first run, which since it's now set up with some information about us, it will no longer need. And we can see some technical matrix looking output. And once that has completed, we are met with the NVIDIA logo. And we now are brought to our desktop on Ubuntu. And we can see that it has the stylized NVIDIA background. So everything has loaded and set up all right. And we do have, like I said, a few other things to actually go through. But I am going to go ahead and quickly change the screen resolution here, which you likely will not need to do. I just need to do that because of the way I'm recording the screen. So now that my screen resolution issue is fixed, which is only because of the capture card I'm using and you won't have to deal with that, there are just a few other things that we need to go through for the Ubuntu setup, and we can just skip for online accounts, skip for Ubuntu Pro. Personally, I would rather not send system info, and location services no, and then basically we are all set. I'm just going to pass on updating the software right now, and we can see that right now we are met with our first real look at the Jetson Jetpack operating system and the Jetson running and its desktop. So I had touched upon this in my previous video of this, but something that I think is really cool about this is up in the top right corner here, we have basically our power selection mode. So we have 15 watts, which is kind of the mid-range. We have 7 watts, which is more if you were using this in a battery-powered edge scenario. And we have max N, which allows the full power output and performance of this Orin Nano. So for what we're going to do right now, I'm going to click max N, and we are on full power. Following that, just kind of some cool things. There's the Jetson Power GUI, which essentially will show you the system, like the processor frequency, the GPU frequency, the temperature, voltage, fan speed. If you go over here in thermal power monitor, you can see your fan speed as well as your thermal throttling limits and shutdown limits. Not super necessary for a basic beginner's tutorial, but just kind of cool to be able to see. So we do have some shortcuts on the screen here. However, for what I'm going to do, we are basically just going to go ahead and start the first example on this, which will be to go ahead and run Ollama so that we can speak to an LLM that is running locally on this Jetson. We're now going to go ahead and actually run a local LLM on this Jetson. Now to do that, we are going to go into our applications here and click on the Chromium web browser, which we installed previously. Now we are going to once again go back to the Jetson AI Lab website. And this time we are actually going to be looking at these tutorials a little more in depth. Now, for the first and likely the most approachable tutorial here, we are going to go into the text generation option. Now, when we click on this default, it brings us into the text generation WebUI, which is a very cool, very powerful web interface to actually communicate with a local LLM. However, for the scope of this tutorial, which is aimed more at the beginner, this can get a little bit complicated to use, and I still end up getting confused while using it sometimes on some of my other machines. So because of that, we're going to go one down here, and we're going to click on Ollama. Now, Ollama at the core is extremely simple in it allows us to actually just communicate with an LLM through the terminal. So about as simple as you can get. Now, understandably, people want to actually have a ChatGPT style web interface to actually be able to speak with their LLMs. So we are actually going to go ahead and not only install Ollama, but also set it up in a way that we can actually use a web interface to communicate with the LLM that we download. Now, I must admit that the instructions here perhaps did not speak to me in the way that I would have hoped they would have. Now, we can simply just install Ollama natively, and just by typing this into the terminal, we will have Ollama on our system and basically be able to communicate with the model through the terminal. However, that is not the most fun for a lot of use cases. So instead of that, we're going to look at what's called Jetson containers. Now, essentially, these are Docker containers, and you may have heard of Docker, but if you're not very familiar with it, then I'm in good company because I'm not either. So basically, we're just going to go together and go through this and actually figure out how to get this done. Now, the first thing we actually need to do is leave the Jetson AI lab and actually go to GitHub. So if we search for Jetson containers, we are going to see a GitHub repository here for those containers. Now, it is Dusty NV who is the author, and the name of the repository is Jetson Containers. So this is actually an extra step that needs to be performed to do some of these things, and I just wish it just kind of was a little clearer about that here, because it could lead to some confusion. So that's part of the reason I wanted to make this video. Now, when we are here in this GitHub repository, we are going to see a bunch of options here and folders and things like that. To begin, we are going to click on Docs, and once we are in there, we are going to click on the setup.markdown or setup.md. Now, all we need to do for the purpose of this simple tutorial is clone this repository by just basically copying this command and entering it into the terminal application. Now, to open terminal, it is quite simple. We just double click on the terminal icon on the desktop, and we are going to just paste this and press enter. And essentially, this clones this repository onto our local Jetson Nano and allows us to essentially utilize some of the setup of this repository that makes it simple to play with the Jetson containers. So we're going to give that a little bit of time. And it is going to prompt us for our password that we entered when we were setting up the operating system. And it will ask us if we want to agree to download this amount of files. That's just standard kind of Linux functionality when pulling repositories and things of that such. Now, that is completed. And we do see here that if we are only going to be running containers and already have enough disk space on our root drive to download them, we can skip the rest of the steps below. Now, I personally like to just be thorough and actually go through these steps. However, because these do kind of touch upon actually having to use the NVMe as well, I'm going to save this for the last portion of the video, where essentially we will go through these steps because that's what we're actually going to need to do to actually start using the NVMe we installed as well. So, however, for the purpose of just getting started, once we've done this, we can basically just go back here to the Ollama tutorial on the Jetson AI Lab. Now, basically, because we're not doing the native install and we want to do the Jetson container, we can essentially just go ahead and copy this, paste it into the command line here, and then press enter. And once we do that, it has found a compatible container from this GitHub repository, as we can see right here. Would I like to pull it, which means download it on my system so that I can use it. And to that, I will make sure I'm in the terminal, press Y, and press enter. And basically, at first it will say it's unable to find the image for this locally, so then it will go ahead and begin to download it from the Jetson Containers repository. And depending on which example and which container you are downloading, this could end up taking a significant amount of time, as we will see later when we are going to do the image generation one with the Stable Diffusion, it's a decent size download. So it can take some time. We're basically just going to let this run. And then once it's completed, we're going to go ahead and move on to the next step, which is actually running the Open WebUI. So we can actually have a web interface for this. Now, as we can see, our Ollama server has been started. And from here, we can run a command, ollama run llama 3, which will go ahead and pull the llama 3 model. However, I want to pull a simpler, smaller model so that I still have some overhead on this machine to actually go ahead and like mess around with the GUI and stuff like that while we're doing the tutorial. So for that purpose, I'm just going to copy right here, ollama run llama 3.23b, and I'm going to paste that in right here and press enter. And essentially this will go ahead and actually download the Llama 3.2 3 billion parameter model, which as we can see here is around 2 gigabytes. So upon completion of the download of the model and a few other pertinent files to the model, we will actually be able to go ahead and converse with this model from within the command line. Now, since that's not necessarily what we want to do, I'll just probably send it one message and then we will go ahead and actually transition this into a web interface where we can communicate with that model. And now we can see that everything has successfully downloaded, and essentially through this we can speak with our LLM from within the command line. So I'll just send one simple message just to give us a taste of how this is. And it will likely say, I'm an AI, I don't have feelings, but I can help you with something, so what do you want? Yep. Okay, so that is essentially the most basic kind of thing you can do with this in terms of running a locally hosted AI. So this is at the core running Llama 3.2 3B locally and completely offline on this little Jetson. Now we are going to go ahead and run Open WebUI so that we can actually basically speak to this model how we did in the terminal, but in a nicer interface through the web browser. So to do this, I'm going to go over here to the Open WebUI little link over here in the left-hand pane, and I'm going to scroll all the way down. And since I have the Ollama installed, since I have Ollama installed, I can basically copy paste this command into a new terminal. Now, if I double click terminal again and paste this and press enter, we're going to notice that it's going to give me an error. It's going to say invalid reference format. And you could potentially kind of like tear your hair out trying to troubleshoot this one. So it is really just a simple fix. So copy this command, open a text editor or something like that, and paste it. Now we'll see if we go up one, do you see how there's one space after this slash here and there isn't on any of the other ones? So all we do is remove that space and then we can go ahead and run this command properly. So it is really just like a tiny white space error that would prevent it from running, which can be a little frustrating. And then once again, as we saw before, it is unable to find the image locally, so it is going to go ahead and download it. And it will again take a little bit of time, so we'll just kind of let this run. And once it's done, we'll go ahead and actually be able to play with our LLM from within our browser here. We can now see that it has successfully downloaded, but it doesn't really give us anything here to work with, so it kind of almost seems a little confusing. Now, what we're going to do is just navigate to the actual web address that this will be running on, which is on our local Jetson at port 8080 or 8080. So if we go back here into Ollama, I do believe the URL for that should be listed right here. So we can see HTTP Jetson IP 8080, which, all right, so we'll go right here. But instead of saying Jetson IP, which obviously is not going to work, we are going to just type 127.0.0.1 and make sure that there is a colon followed by 8080. And once we do this, we will be brought to nothing. All right, hold on one second. Connection refused. That is, oh, okay, give it a second. All right, good. Yeah, because that didn't make a lot of sense. So you can see here, it's struggling a little, but it is doing a lot. So basically we are met with this kind of odd page. So we're just going to click get started, and it wants us to enter this info. This is essentially just a formality. It all stays local and you can put whatever you want. So, and once I do this, I'm just going to click create admin account. Sure, we can save it. We can just close this, and we are going to select our Llama 3.2 3B. And basically, we can just now go ahead and speak to the model in kind of a way that you would on like ChatGPT or something. So just perhaps a bit more familiar. You know, it is possible that I've made a mistake. Don't quote me on this, but I probably shouldn't still have this session here. So I'm just going to type slash by here, and that will kind of exit the communication space that I was having with Llama 3 in that terminal. So hopefully that'll free up a bit of overhead. Okay, so that potentially was a mistake on my end. So, but I'm going to leave it in and show it so you don't do the same thing that I do. And we can see, okay, it is just basically telling me about the Ford Mustang. Okay, this does seem to be more or less correct. Sorry, I'm like getting like fact checky on it. All right, but yeah, I mean, you can see here, like it's really solid. How fast is it? I don't know. And you can play with the models and things like that, obviously, at home. Okay, and then it just gives me an response like this. Now, I notice sometimes I see the system throttle due to overcurrent message. So essentially what I do when I see that is more or less just ignore it. So I go in here and I click acknowledge warning, and then I X out of this. I press close. I go back into here, disable notification under settings, and then we basically, once I close this, won't see it again. And it is just giving me a large amount of top speed lists of the Mustang. So very cool, and just a cool way to actually be able to run a local AI on your local Jetson. Now, there is something a bit cooler about this, which we will quickly touch upon now. So one of the things that I thought was very cool about this and want to showcase is that this can be used as a remote local AI server. Now, what do I mean by that? The easiest way is to just show you. So the first thing we're going to need is the IP address of our little Jetson. And to do that, we can click on the top right in the menu bar here and just go into settings. And then under network here, whether we're on Wi-Fi or whether we are on Ethernet, we're just going to click the settings next to whatever interface we're using. And we can see right here that we have the IP address of our Jetson. So now what I'm going to do is take that IP address and actually move on over to a different computer here. So pardon me as I move the mic. Now this computer is on the same local network, but that is the extent to which they are connected. So if I type in that IP address, and then enter the port that the WebUI is running on, we actually go ahead and go into the WebUI. Now, I have done this once before, so I didn't have to log in, but I would just have to put in those same login credentials I entered when we first ran it on the Jetson. But basically, you can see here's the continuation of my chat about the Mustang. Can it burn out? I know that's like silly, but, and then basically, so what you can see here right now is that this machine is using that as an AI server. So that's basically like a little chat GPT right now in my house. And it's able to be accessed from other network devices, which is, this is something that I think a lot of people will have a good use case for and want to be aware of. So yeah, I mean, it's talking, it's telling me how to burn out and like, okay, again, whenever, all right, you get the gist. So that was the kind of local LLM and local hostable network LLM portion of this. Now we're going to go ahead and do one more simple example, and that is running Stable Diffusion locally on this little Jetson. Now we can see here in the left pane, there are a few options for actual image stuff and graphics and things like that. So if we just go down here to image generation, we can see that it does actually mention Flux and Comfy UI as well as Stable Diffusion XL. However, with some of these, when you click on them, it will tell you which Jetsons these will actually run on. Now, there is a family of Jetson devices. So unfortunately, this is not really going to run on the Orin Nano currently, as it says they're still fine-tuning the model for the Orin Nano. And that is the same for Stable Diffusion XL. We can see that you need the AGX Orin 32 or 64-bit. However, fortunately, we can just go ahead and run the base Stable Diffusion, which, to be able to do this anyway on a small SPC like this, SPC is a single board computer, I still think is fantastic and very cool. So basically, since we've already gone ahead and set up the Jetson containers and things like that, we can basically just use the auto tag to go ahead and pull this container and run it. So again, we are just going to open terminal. We are going to paste the command from right here, and then we are going to press enter. And it will ask us for our password. And once we do this, we'll get the message saying it didn't find it locally, so would we like to get it from the repository? And to that, we type yes or Y and enter. And we can ignore that version mismatch. And then we should see, after a little bit of time, that it will begin to get the container and set it. So, as we can see here, this did not work. Now, it is quite frustrating because this took a rather long time to actually get the container together and download it and everything like that. Basically, the error right here is just saying that it can't find pip from Python 3.6. So here's what I'm going to do. I'm just going to hit clear. And for this one, instead of using the auto tag run, we are going to specify the container that we want to use, which in the case to get a working one on a freshly loaded Jetpack Nano like this is going to be 36.2.0. And then we're just basically going to have to wait for all of that to happen again. And it's going to go ahead and download everything. So this is essentially we're manually pulling this container or explicitly specifying one of the container images above. So for our use case, and basically what I have found out is that if I use one of these that is not 36.2.0, it's going to fail with some form of error that you're just not going to want to troubleshoot or have to deal with. So we're going to pull this, and it's going to take a little bit of time. However, upon conclusion of this all downloading, it should work properly, and basically at that point, we will just be ready to go into the Stable Diffusion Gradio web interface and do some image gen. So we can see that with the correctly specified container of 36.2.0, everything loads correctly. It downloads the necessary files. And if we scroll up here, we can see that we now have a local link running on our default local address at port 7860. So if I control and click that, we will in a second be greeted with a Gradio web interface for Stable Diffusion 1.5. Now, once this checkpoint has finished loading, which seems to happen rather quickly, we can basically just go ahead and begin to generate images. Now again, as this is more of just a setup tutorial, I'm not going to really be testing it, but I want to just do one thing. Let's keep with the Ford Mustang theme. You know that? Why not? I don't actually have a Ford Mustang, just to throw that out there. I just it's what came to mind on a whim. So it is 3 in the morning. So all right, and we can see we have our estimated time of arrival. Ooh, not bad. That's like a Grabber Blue like GT, probably around like 2012, 2013. You know what? I have to say that did better than I thought it did, and prompting is rather like a large part of the consideration when using Stable Diffusion. So my prompts are horrible. So this did pretty well given the lackluster prompt. All right, let's just try one more of a Ford Mustang doing a burnout on the Las Vegas Strip, AK realistic. And we can see that generates. Okay, so if you're not a car person, you might not know why I'm laughing. this is insinuating that the vehicle is front-wheel drive because that's where the smoke is coming from, and that is not quite the case. However, the other elements of the strip are absolutely rather decent with the sort of palm trees and the casino/hotel looking buildings. So overall, pretty cool. And again, that's Stable Diffusion running locally on an SBC for $250. kind of cool, you know? All right. So the last thing that we are going to take a look at, and this may not be applicable to you depending on how you set your Jetson up, but I want to finish up with actually getting that NVMe properly set up, recognized by the system, and usable for us. So if we do go back to the Jetson AI Lab website and we scroll all the way down, we do see that there is a link in the sidebar for SSD plus Docker. And this is essentially the instructions on how to actually go ahead and get this all set up. Now, we already covered the physical installation of this. So the next thing we are going to do is pretty much just follow all of these steps, kind of how they're listed here. Now, I have not actually done this, so I'm doing this at the same time for the first time as I'm recording it. So I'm just going to run through it and we'll see. So we have our PCI bridge, we have a network adapter, we have our Ethernet controller and non-volatile memory controller. Okay, let's see. Seems all right. So I would assume that this is the one that we are going to be looking at, and we should find out more later. So if we run lsblock right here, and basically, like I said, I'm just copy pasting these commands just through, and we can see that our NVMe is recognized. Now, there is a lot of verbose output that gets shown here. So for the purpose of what we're doing, we can see, okay, we have one disk that is 238 gigabytes, and then we have the NVMe, which is 238.5 gigabytes. So that there are two 238 gigabyte recognized disks shows us that one, our micro SD card, and two, our newly installed NVMe SSD. So we can go ahead and basically continue now that this is going well. So we need to format the SSD, create a mount point, and mount it to the file system. Now, when you are going to do this, it is very important to ensure that the actual name that you put right here is exactly what is listed here. Now, in my case, this is exactly the same, so I can go ahead and just copy paste this in, but you do want to make sure whenever you're doing any sort of file system modification stuff in Linux, it doesn't necessarily have the safeguards that like Windows or Mac would have, where you will be warned before like destroying something. So we are just going to just press enter, type the password, and okay. So whatever that step did is now all set. And now we are going to make the directory SSD, which is the next step. So sudo means run as superuser, make directory, and the name is SSD. And now we are going to mount said directory. So, and I'm just following along. If I incorrectly extrapolate one of these commands, just ignore it. Just follow along like I am. In order to ensure that it persists after boot, we need to add the entry to the fsub file, identify the UDID for the SSD. So we are going to once again run this, and we need to see the UDID for our SSD, which will be listed right here. So we're just going to copy that for safekeeping. And we want to insert the following line, replacing the UDID with the value found from here. Okay, so I am going to open the text editor just to be able to actually save this command, and this is something that's you'll probably want to do as well. So basically, we're going to copy this. We are going to paste it right down here, and then in place of these asterisks, I don't know what the plural of an asterisk would be, and we just paste it like that. Make sure not to have any random like extra spaces or anything like that. Linux, especially the command line, is very sensitive to stuff like that, as we saw earlier. So In order to get this correctly set up, we are now going to run this command, which remember, so basically where we were is we had just run this, and now we are going to run this to add a new entry into this file. So I am just going to clear the output of the terminal to give us a little more breathing room there, and we'll paste that in. And once we are in here, you know what, I'm closing this terminal and I'm not saving that. So, oh, because it opened it in VI. Okay, that's a more in-depth text editor. All right, here's what we're going to do. So we don't want to use VI being beginners because it's rather difficult to use. So we're going to open a new terminal, and we are going to do a little bit of extra work, but trust me, it'll be worth it because it'll make your life way easier. We're going to type sudo apt-get install nano. And what that is going to do is install the Nano text editor, which is a terminal text editor, but it is far simpler to use than VI or Vim or whatever you want to call it. And it will perform the same functionality in actually being able to edit this file and things like that. Okay, so now that we have Nano installed, we are going to take this, and I'm just going to paste it in here so that I can actually modify it a bit easier. So instead of VI here, we are going to type Nano. Now once we do this, we will... Yes, I'm going to open anyway because that was the one that I'd closed that I'd kind of messed up. Fortunately, none of my changes had persisted, which is nice. And you can see that this is quite a bit easier to use, as I can just kind of use the arrow keys to get down there, go ahead and paste this, and then Control O to write out, press Enter, and then Control X to save. And now we are all set and can move on from that step. So now we are going to change the ownership of our SSD directory, which is what the chown command stands for, which is change owner. And it is just going to change the owner of the directory to us, I believe. So we have already had, okay, so we can skip this step here since we did earlier install all of the Jetson containers and things like that. And because we have the Jetpack flashed SD card. So I can go ahead and, I'm just wondering which step it's telling me that I can actually skip. Okay, so we're going to start from here where we add our user to the Docker group. So that is restarting Docker. It is adding us to the Docker user group. Now that that is done, we are going to continue from step 3 right here. However, if you recall, we do not want to use VI as a text editor, as it is just kind of a little bit more difficult than what is necessary for someone beginner or someone who doesn't want to use that. So we are just going to change that command to sudo nano, and we are going to paste it, and we are now in. And basically, we just need to copy this and paste it. We are going to insert the default runtime. So basically, you know what I'm going to do? So in Nano, if you don't do that, if you bring your cursor to the top and just do Control K until there's nothing left, that will just delete everything. So I've done that, and now I will copy this, I will paste it, and then once again we do Control O to write out, and then Control X to save. And now we are just going to go to step 4 and restart Docker. And that'll take a little time. All right, and now that that appears to have successfully completed, we are just going to continue down here. So we are going to stop the Docker service again. I'm wondering if that whole step was, okay, so I now believe this whole step was what could have been skipped. So whoops. Oh well, that's the downside of doing this all on the first run live on camera. So now that we have done that, we are going to move the existing Docker folder. So I'm just going to copy paste this one in and hope that it is successful. All right, this is a good sign. As it appears, it is going to be moving our Docker folders and containers and related files. So after a good length of time, we can see that 35 gigabytes worth of files have been moved to the SSD. Now, there are just a few more steps that we need to go about doing, and one of those is, once again, to edit this docker daemon.json. And remember that we have switched out VI for Nano just to make things a bit easier. So I am going to clear the terminal just to have it be less cluttered, and press enter. And I am going to just copy this. And in Nano, as I had said, if you press Control K, it will cut the line that your cursor is currently on. So if we do that enough times, the old one will be removed, and we can paste in the new one, and then do Control O to write out, press enter, and Control X, and that should satisfy the step 3. Now we are going to rename the old Docker data directory by just running this command right here, and works quickly, which is good. Now we are going to restart the Docker daemon so that we can again go ahead and actually see if the changes worked. So you can press Q on the keyboard to get out of like that if you're stuck and you want to get back to your main command there. So now our next step is to test Docker on the SSD. So we are going to open a terminal to monitor the disk usage while pulling a Docker image. So we can go ahead and close this text document. We are going to paste this and press enter so we can see the utilization of our disk, which is down here. And essentially to do this, we need to open a new terminal and just start a Docker pull just to test it. So we're just going to pull L4T, which is Jetson like board support thing. So we open a new terminal, and also you can press Control Alt and T as well on Ubuntu systems to open a terminal, so you don't actually have to click the icon, just as a little shortcut. So we will begin to pull this, and if the disk usage on SSD begins, okay, so we need to type sudo and then, which shouldn't have to because we should have been added to the Docker group, but it is what it is. All right, and we can see that out of all of these drives right here, the one that is being modified, meaning there is more space being utilized on it as this gets downloaded, is our NVMe. So based off this output, we can conclude that this has properly worked. And there is a final verification. So, okay, all right, we'll run that. Okay, so we are going to reboot our Jetson and just do this. So we have now rebooted it after making all of those changes, and everything should be pretty good, aside from the fact that I seem to have misplaced this. Okay, good. I didn't save it there. I saved it home. So we are just going to verify by running these commands. So we are going to run this to search for the NVMe line and type the password. And we can see that we do get an output just like this. So that is a good thing. Following that, we are going to type df-h, which is disk-free human readable. So how much disk space is there, but in a human readable format, so we don't just see a bunch of random numbers. And we can see that our NVMe has 36 gigabytes of space used now, which does track with having moved all of our Docker containers and things of that sort onto the SSD. So basically, this does seem like it has gone all right. I do have to say I'm a little curious as to how much is still used on the micro SD card. So I should probably make sure that the old Docker files and everything like that were actually cleaned up and removed from that. So let's just continue running these commands. But at this point, it has worked and it's all set. But just for continuity, we will do this. Okay, so the root directory for Docker is now correctly under the SSD, which is what we wanted. And let's list all of the subdirectories of that folder, which is what this command will do. So we can see, okay, we have all these, which is good. And following that, I don't actually really know what this command does, but we're just going to run it anyway. Famous last words. Okay, so it should just tell us how much space is used on the on the SSD, so 40 gigs. And then we want to make sure that the root runtime for our Docker instance is NVIDIA, which it is going to be because we did add that. So the default runtime here is NVIDIA, and the Docker root directory, as we saw before, is SSD Docker. And with that, that essentially concludes our NVMe SSD configuration. So definitely a little more intricate than just like popping an NVMe into your desktop and just being able to use it, but such is the case with Ubuntu and Linux and AI things. All right, so that is going to conclude this hopefully thorough setup guide. I do believe this is probably going to end up being around 45 or 50 minutes or so. So apologies if you don't like long drawn out videos, but I really did want to provide something that would essentially give an avenue for someone who bought one of these and does not have a lot of background experience in any of these technologies. So I just hope that you can use this to get it set up and going and have some fun. And basically, yeah, I'm going to continue using this and doing some fun things with it. I'm very interested in some of its capabilities. So specifically with object detection and actually being able to run Whisper, which is a speech to text. So basically it will transcribe your speech, and you can use that to talk to an LLM and things like that. I didn't actually show the example that allows you to kind of speak with an LLM or a multimodal one, as it didn't specifically list running on the 8 gig Orin Nano. So it wasn't something that I wanted to try to mangle into a more beginner focused tutorial. So that's really going to conclude the video. I hope this was of some benefit, and yeah.